acceleration is 2t equals dv dt. I want to solve it for v, for velocity. Start with Roger, see if we can work our way around the room to see how we might solve this. Roger, what might I do next?
Start the integral.
Okay, and
So it would be like some whatever 2t to dt.
so integrate both sides?
Yeah.
Not quite yet. The reason I can't quite yet is I don't have all the t's on one side. I haven't yet separated. So this kind of equation where I have a derivative equals something is technically classified as a differential equation. And I have different techniques. The easiest technique, if you can use it, you can't always use it. You learned lots of techniques last fall. The easiest technique, if you can use it, is to separate, get all the t's on one side and all the v's on the other. So let me come back with Roger. What would I do?
Both sides by 2t.
Okay.
Then integrate both sides.
Yes.
That way you get like a function equals to.
Okay. Now when I integrate both sides, I need to put limits on here. This side is t, so my limits are on t. T equals 0 to t equals some final time t. My starting off time is 0. My final time is some arbitrary time t. What are my limits on the right-hand side, James?
It goes from v equals 3 to v equals v.
Yep. I won't always write v equals 3 to v equals v. Because there's a dv there, that tells you the limits must be velocity. I have no choice. So I put it on this side just to be super clear, but I think normally I would just write my limits are from 0 to t. Implied is that it's from time equals 0 to time equals t. For the right-hand side, it's from 3 to v. All right, now we'll go ahead and do these integrals. Integral of 2t dt, Eric.
Squared.
And this right-hand side, Fred. Yep. Now I put in my limits. I put in the t in for t squared, and I subtract off the 0 in for t squared.
Why is it 0 to 3?
Oh. That's my, every 20 things. Should be that. Okay, I put in the limits on the left-hand side. What do I get, Sean?
Just t to the squared?
Yep.
T to the squared.
And putting in the limits on the right-hand side, what do I get, Benson?
Minus 3.
So v equals t squared. When I move the 3 over, Edgardo, what do I get?
T squared plus 3.
Yep. Okay. So I've now got velocity as a function of time, which is t squared plus 3. Looking at this equation, what units does the 3 have to have? Anybody?
Meters per second.
Meters per second. Yep. Because the v is meters per second. That 3 better have units of meters per second. It looks like we have a units problem. We don't. But the reason is a little bit subtle. T squared by itself would have units of seconds squared. So it looks like I've got meters per second plus seconds squared. Can't work. Problem. What's going on here is that I used to have a 2 here. When Fred integrated, he did the 2 divided by a 2. And that's how he got the t squared. It was really the 2 divided by 2, which gave him a 1. Because the integral of t is 1/2 t squared. So that 2 is from the 1/2 t squared. That 2 is from the 2 that was already there. So what I really got here is a 2 over 2 t squared. And that 2 has some units to it. Let's see, what units does this 2 have? Well, the acceleration is equal to 2t. Okay? What units does acceleration have? Zach.
Meters per second squared.
Okay, so that side has to be meters per second squared. What units does the t have, Max?
Seconds.
So what units does the 2 have to have, anybody?
Meters per second cubed.
Yes. So that 2 has to be meters per second cubed. That 2 is the same as that 2, is the same as that 2, is the same as that 2, is the same as this 2. So that has units of meters per seconds cubed. Meters per seconds cubed times seconds squared gives you meters per second. So the units do actually all check out, although it looked like they weren't going to. The reason they looked like they weren't going to is the 2's canceled, but when I did the integral of t to get 1/2 t squared, that 1/2 has no units. So it made it look like we had no units when we did it. So this is correct. Our answer for velocity as a function of time is t squared plus 3. And now I'd like to figure out position as a function of time. So I started with acceleration. I did a couple minutes of work and I got velocity. Now I'm going to do a couple minutes of work and get position. I'm going to erase this.